Hi, GM, and welcome to Brainrot Breakdowns Episode 2. In this video, we're going to learn about Succinct, In this video, we're going to learn about Succinct Network in 3 difficulty levels: Noob, Pro, and Trenchwarrior. I'll also briefly cover SP1 because that is what powers the network, and both of them are products made by the same company, that is Succinct Labs. It is a company that wholeheartedly welcomes brown representation, and that's part of the reason why I am making this video. Some notable figures include Umar Roy, John, I don't know how to pronounce this, Walter White, and Lean Boy Carty. Okay, that's enough yapping. Let's get to the explanation. You first need to understand how zero-knowledge proofs work. So I'll give you a very simple explanation with an example. Imagine that you want to prove to your friend that you have a succinct testnet code without actually showing the code to them. How do you do that? Simple. Just visit testnet.succinct.xyz and show them that you can access the games there and earn stars. This is kind of how zk proofs work too. In Succinct's case, the proof needed is that a program was run correctly. There are already ways to generate and verify such proofs using circuits. However, writing circuits is basically torture for devs, and that is where Succinct shines. It allows developers to write code in more normal languages like Rust and C++. And using SP1, they can prove its execution without writing any aneurysm-inducing circuit code. Succinct Network can be thought of as a marketplace of proofs. You can generate zero-knowledge proofs for any piece of software, whether it's a blockchain, bridge, Oracle, AI agent, video game, or anything in between. And it will aim to give them the cheapest yet the most efficient proof. Now, what does that mean? Let's explore. The core mechanism of Succinct Network is formed by the concept of proof contests. Proof requesters specify a fee, deadline, cycle count, which is computational complexity, among other parameters, while provers bid for these requests in an all-pay auction. Relax. I'm aware that you don't know what an all-pay auction is, so I'll explain it. In such auctions, everyone who wants to bid pays their bid to the auction host upfront. The one who wins this auction gets to generate a zero-knowledge proof for the requester's proof request, and it can be verified by anyone. The profit of a prover would be fee collected minus their bid, minus the cost they incurred to generate the proof. To prevent bad actors, provers must deposit collateral before participating. If they win a bid but fail to deliver on time, their collateral gets slashed. It's not necessary that the prover with the highest bid will always win, because the process of selecting the winner is probabilistic, not deterministic. This is done to prevent centralization. The highest bidders would be those with extremely good hardware, because their profit margin would be high since it doesn't cost them much to generate proofs. If proof requests were to always be given to the highest bidder, you'd end up with one prover or a small group of ultra-rich provers hogging all the proof requests. The approach by Succinct lets smaller provers occasionally win, earn fees, and gradually upgrade their hardware. For example, let's say the requester wants a proof for his program and he sets the fee to $100. Prover A says he'll pay $40, B says $45, C says $46, and then D comes in with his juiced up RTX 6969 and says he'll pay $75. D will have a higher chance of winning the bid, but it is not necessary that he'll win. Now, how does that work? Let's dive deeper and find out. To explain how exactly the winner is decided, we'll need a bit of math. So if the only number you've seen in your life is 0, skip to this timestamp and save yourself a yap session. Thank me later. The probability of winning is given by BI. Stay with me now. I know this looks a bit complicated, but it really isn't. BI represents the bid of prover I, as in prover 1, prover 2, etc. Similarly for BK, where K goes from 1 to M, which means the bid raised to the power of alpha for each prover is summed. Alpha is basically a measure of how much priority the highest bidding prover should be given. If alpha is 1, the highest bidder has a significantly higher chance of winning, because in this case, the probability of winning is directly proportional to the bid amount. On the other hand, the closer alpha gets to 0, the more equal are the chances of the bidders winning. This alpha value can be decided by the protocol. The bids of the losing bidders can either be given back to them or instead given to the requester as rebate. If, like me, you're devoid of beefy hardware, that's fine too. You can join proving pools to both contribute to and benefit from the network. Think mining pools, but instead of mining crypto, you're generating zk proofs. You might be thinking, what if I keep reusing my work for different requests which have the same parameters? Well, nice try, Diddy, but that's not possible because the nonce generated at request time is embedded into the proof. Moreover, there is a mechanism to prevent your proof from getting copied too. You see, the address of the prover is embedded into the proof during proof construction, so it becomes impossible to copy someone else's proof, and you would essentially have to just generate one from scratch. And that is how Succinct Network works. I think Succinct Labs is a team that just keeps on shipping good stuff, not just on the protocol side, but also on the user-facing side, like all the games that we had. My favorite one was Ferris Volleyball, and I'm quite sad that I can't play it anymore. With Vitalik's recent article about moving Ethereum execution towards RISC-V machines, Succinct might just end up playing a huge role in scaling Ethereum. They also recently introduced the concept of VAPs or verifiable apps in partnership with Layer 0. So that's a video for another day. Thank you so much for watching. Let me know what you think about the video in the comments. My next one is going to be a dev tutorial on how you can generate your first proof on Succinct Network. I hope to see you there.